This is 11th lesson, second topic, factor affecting radiographic image density. There is different images, the high kbp and amaze. Next is amaze. Amaze is exposure rate high, low and medium. The amaze is produce of a may and exposure time in a second. Any combination of a may and time that will produce a given amaze will produce identical radiographic density according to the reciprocity law. According density and amaze are the quantitative factors and radiographic density and amaze quantitative factor and directly related. Doubling the amaze will double the radiographic density. Half the amaze will reduce density to half. At least 30% changes must be made in the amaze. There to be participation changes radiographic density. Next topic is SID. So the law is use the inverse square law to determine the next exposure rate at the distance. I1 upon I2 equal to D2 upon D1 square. D2 square upon D2 square upon D1 square. The next is use the density maintain formula. Formula to determine what changes in amaze required to maintain the original radiographic density by using directly relationship equivalence. Amaze S1 upon amaze 2 D1 square upon D2 square. Summary: relative small changes in SID can have a significant impact on image optical density. As the SID increase, exposure rate and image density increase. With the changes in SID, the inverse square law and used to calculate the new exposure rate. With the changes in the SID, the density maintain formula used to calculate the new amaze. The next topic is kbp. High kbp, less kbp, medium kbp. Summary: increased kbp produce more high energy X-ray photon. Example: rate of increase. An increase in kbp will result in increase in radiographic image density. Decrease in kbp will result in decreased radiographic image density. When amaze manipulate is not possible, radiographic image density can be doubled or halved by using the 15% rule. Next topic: intensify screen. Summary of this topic: intensify screen amplify the action of the X-ray through their property of the fluorescence. All other factors remain constant. An increase in the screen speed will result in increase in the image density. Screen speed and image density are directly proportional. Screen speed and patient dose are relatively inversely proportional. Screen speed and X-ray tube heat production are inversely related. Screen speed and image resolution sharpness are inversely related. Next topic is grid. There is the grid. We will discuss the grid, various type of long, oblique, and filter the radiations, the height of grid, distance between the height of grid and width of the intraspace material. So next grid conversion factor of the various radiographic grid ratio and conversion factor. No grid 1, 5.12, 6.1, 6.13, 8.14, 10 point or 12.15, 16.16. Next we will get the summary of this grid. The scatter radiation is a result of the X-ray photon interact with the tissue by the Compton scatter process. The scatter radiation at the image degrading density to the radiographic image, increased density and lower contrast. For contrast radiation, the production of the scatter radiation increase with increase in the field, Kp and thickness and volume of tissue. The single most important way to decrease the production of the scattered radiation is collimate. The amount of the scattered radiation reaching the image receptor is decreasing through the combined use of the collimator and the grid. The grid are made of the alternating strip of the lead and the radiolucent material. They are placed between the patient and image receptors to absorb the scattered radiations exiting from the part. Grid may be stationary or the moving parallel or focused. Focus grid require that the correct surface be using X-ray tube, not upside down. Tube angulation parallel to the lead strip. The long axis of the X-ray tube and grid surface are the parallel. The SIT should be within the straight focusing distance range and the X-ray beam should be not be off centers laterally with the center of the grid. If the focus grid require are not met, the resulting image will demonstrate to lose density and as a correspondence of the grid cutoff of the primary beam. The most common way to expressing grid efficiency by the grid ratio and the number of the lead strip per inch. Because grid remove many photons that would have contributed to image density. The adding of the grid requires significance increasing in the MAS. When implementing the grid or changes grid ratio, a grid conversion factor must be used to determine required MAS changes in the order to avoid the undesirable changes to radiographic image density. Next topic is filtration. Filtration, we will see different filter. We will see summary. When the anatomic part of the greatly in the thickness or tissue compositions, compensate filter may be used even out radiographic density. The ordinary X-ray and tube filter of 2.5 mm all has no effect on the radiographic image density. Compensation filter side into place by means of track on the collimator housing. Compensation filter are available in various shape or their thicker positions absorb more of the X-ray beam are and therefore placed over the thinner body part, while their thinner portion absorb fewer X-ray are placed in thicker body part. Patient factor: ascites, rheumatoid arthritis, Paget, pneumonia, atelectasis, congenital heart failure, edematous tissue, adding the pathogenic conditions. And the example: destructive pathogenic condition, osteopenia, osteomalacia, pneumopathy, peritoneum, emphysema, digestive arthritis, erotic and neurotic conditions. Summary. Variation in the tissue density will note the radiographic density varies in the X-ray image. Normal tissue density difference exists as a result of body habitus, age, gender, and level of activity. Abnormal density differences exist as a result of the trauma or the pathologic conditions. The radiographer must be acknowledgeable about the conditions affecting normal and abnormal changes in the tissue density to make accurate selection of the technical factors. Correlation factor: single phase, double phase, three phase. This is the single phase, three phase, 12, three phase, 12 plus high frequency. Summary: three phase equipment produce nearly peak potential voltage whenever a single phase voltage drop periodically in the zero between the voltage peaks. MS is usually adjusted to compensate the difference between the 1 and 3 waveform equipment. When the changing from the 1 to 3, 6, 2/3 less MES will require. When 1 to 3 to 12, 1/2 of original MES require. The reverse is true when the changes from the 3 to 1. Next is beam restriction, anode Hill effect processing. The anode Hill effect emphasizes under the following condition: A. At short acidity with the large cassette with the small anode angle. Next, processing. Then next topic we will get summary of this topic. The chart changing in the size of the irradiated field affect image density as a result of increase or decrease scattered radiation productions. The anode Hill effect is the characterized by the greater X-ray intensity quantitative at the cathode end of the beam. The anode Hill effect must be pronounced at the short acidity with image receptor of with the X-ray tube having a small anode angle. The anode Hill effect can be used to compensate for the difference of the tissue density thickness femur thoracic spine. Radiographic density increases as developer temperature increases and as the replenishment rate and or length of the development increase. Now quick question. Grid ratio is defined as the relationship between the height of the lead strip and the answer is distance between the lead strip. The second one is of the following group of the exposure factor will produce the greatest radiographic density. The answer is D, 200 mA and 100 microsecond, 36 inch and acidity. How the source image distance related to the exposure rate and the density and the rate of image density. Answer is as acidity increase, exposure rate decrease, the image density will decrease. Question: if the radiographer unable to adjust MES yet not adjust reduce the image density of the particular image by the half, which of the following would the best accomplish this? Answer is decrease KVP 15%. Decrease KVP 15%. Next question is The exposure factor 85 kVp 10 mA is used to particular non-grid exposure. What should be new mAs if an 8.1 grid added? The answer is 10 mAs, 8.1 grid, then 40. Answer C. Answer is C, 40. Next question. An X-ray image demonstrate poor contrast resolution can be attributed to insufficient. Answer is beam restriction. The term described image density in the digital imaging. Answer is A, blackening. I think wait. The answer is C, brightness. The term used to describe image density digital imaging is answer is C, brightness. And an exposure was made using 20 mA 50 microsecond exposure and the 75 kVp. Each of the following changes will affect doubling radiographic density except. Here answer is changes to 100 mA. An exposure was made 40 inch SID and using 300 mA 0.12 second exposure and the 70 kp with the 200 film screen combination and the 8.1 grid. It is desired to repeat image and the order to produce improved detail use 48 inch SID 100 film screen combinations and using 2.5 screen second exposure and with the all factor constant. What is the MA will be required to maintain the original radiographic density? Answer is 400 MA. Compared to low ratio grid, higher ratio grid could have taller. Answer is taller lead strip.